Before we get into this actual video, I do appreciate all of you guys that have been watching my videos as of lately. I do make these videos to document my networking journey. As I learn the various technologies within networking, I like to further cement that understanding by implementing the technologies within my home lab. So these labs hold me accountable in making sure that I can implement the technology once I read and also learn about it. And I do not edit these videos to make them perfect. If I make a mistake, I usually keep it in the video just to document my networking journey and as I learn these technologies and my bumps in the road. But that's enough of this. Let's get into the video. Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab video within the lab. Today's video is going to be about route selection and administrative distance. So if you guys want to get caught up to how we got this exact configuration, I did make a video and it's called OSPF demonstration on Cisco routers. It is on my channel. So go check out that video if you want to get caught up with this actual configuration step by step. All right. So basically, just to run through what we did, we configured both of these devices. So this router and this switch, we configured the gigabit Ethernet interface on the router, and we connected that into the connection to the fast Ethernet 01 on the switch, and we can see that connection right here. So they are connected to each other. On the router, it has an IP address of 192.168.1.1, and the layer 3 switch, we enabled IP routing on the switch, so it is operating as a router now. It can route information and it can also switch information. It's still a switch, but it can also route information. Its fast Ethernet 01 interface has an IP address of 192.168.1.2. So they have a network between each other. On the router, we configured it to have a loopback interface of 1.1.1.1. And on the layer 3 switch, we had a loopback interface IP address of 2.2.2.2. So basically what we did was we configured OSPF between both of these devices so they could share these loopback interface networks between each other. And then we were able to ping the other loopback interface on the other device. So that is where we are in this video right here. So what we're going to do today is we're going to look at how a router will adjust this routing table based on the routing protocol that we use. We use OSPF, so we know OSPF has an administrative distance of a 110. But if we configure EIGRP between both of these devices that we have behind us, we configure an EIGRP relationship, then both of these devices will put the EIGRP route inside of the routing table instead of the OSPF route. And that is because of administrative distance. Administrative distance is the believability of a route. So if we have an OSPF route to a network and we also have an EIGRP route to a network, we will choose the EIGRP network or route. All right. And then after we look at that, after we do EIGRP, we will just take the next step and do a static route to the loopback interfaces on each router. And we will see how the routing table adjusts from there. We will see that now we know that a static route is more believable than a EIGRP route. So when we configure that static route is, as a result, is going to end up in our routing table. Okay. So without further ado, let's go ahead and hop on these devices, hop onto PuTTY, and get started. All right, so as you guys can see, we're in PuTTY now, and we're connected to the switch. Okay, so let's do an enable, and let's do a show IP route, just to take a look at the routing table to get started. So we can see our connected routes and our local route, and we can also see the OSPF route. So this is the one we want to focus on. And we can see we have a destination address, a destination network, IP address to 1.1.1.1, and it is through OSPF, and we can tell that by the administrative distance of a 110. And we can also confirm that by looking at this O, we can see that that stands for OSPF up here at the top. So that is how we learned this specific route right here. But what we're about to do is we're about to configure another routing protocol, which is EIGRP, and the routing table is going to adjust this route to be the EIGRP route instead of the OSPF route because EIGRP is more believable. Okay, so let's go ahead and configure EIGRP on this switch. Let's do a configure terminal, and let's do a router EIGRP 1, and that is the autonomous system number, and we're just using that as an example, but these autonomous system numbers need to match between the two devices in order for this to work. All right, and let's specify the network. So we want to do a network of 192.168.1.0. we want to do a wildcard mask of 0.0.0.255 because we want to do a /24. All right, and let's hit enter there. Let's do a network of 192.168. Excuse me. No, we do not want to do a 192.168. We want to do, we're on the switch, so we want to do a network to 2.2.2.2. Yeah. And then we want to do a wildcard mask of 0.0.0.0. All right. Just wanted to, the reason I'm a little slow on that command is I wanted to make sure that the 2.2.2.2 IP address is the one that's actually configured on this switch. Let's confirm that. Let's do a show IP interface brief just to take a look at the show IP interface brief. Just to take a look at the loopback interface IP address. Just want to confirm. Yep, so we got 2.2.2.2 over here. All right. So now we have that configured. So what we're going to do now is disconnect from the switch and plug into the router and do a similar configuration on the router to set up EIGRP on the router. All right, so we're connected into the router now. All right, now let's go on the router. Let's do an enable. Let's do a show IP route on the router as well, and we should see that OSPF route in this routing table as well, and we can see we have a network advertisement to 2.2.2.2 in this routing table, and that is the loopback interface on the switch that we configured. We learned a route to this network via OSPF. We can tell by the 110 and the O right here. Okay, so now what we want to do is configure the EIGRP configuration on the router so our routing table adjusts to the more believable route, which will be EIGRP. So let's go ahead and do that. Let's do a configure terminal on the router, and let's do a router EIGRP. This autonomous system number has to match. All right, so we're going to do 1. Let's do a network of 192.168.1.0 of 0.0.0.0.255 for our wildcard mask because we want to do a /24. Let's do a network, and we see that adjacency came up immediately. So now we have that adjacency, so let's advertise the 1.1.1.1 and do 0.0.0.0/32. Say enter there. All right, now let's do a end, and if we do a show, IP route, we can see now that OSPF route is gone and we have the EIGRP route, and that is because the administrative distance for the EIGRP advertisement is more believable because of administrative distance. All right, so we just seen this routing table adjustment. All right, so now what we want to do is we want to show the how the static route is going to preempt this EIGRP route. We can see the EIGRP administrative distance is a 90, but a static route has an administrative distance of 1. So that is very believable. So let's go ahead and adjust. Let's do a configure terminal. And to do a static route, we want to do an IP route to 2.2.2.2. And we want to do a next hop of 192.168.1.2, because that is the layer switch. That is the layer switch next hop IP address. All right. So let's hit enter there. Oh, did I missed something? IP route 2.2.2.2. Oh, that was the net. I need to put the network mask. So that is actually next. So 255.255.255.255, because it's a /32 route. And then we want to specify the next hop of 192.168.1.2. All right, yeah, that's it. That's the correct command. So now if we do a do show IP route, yep, we can see now we have this static route. This static route has an administrative distance of a 1, so that is very believable. So that preempted the EIGRP route that was just in here. Okay, so we are going to disconnect from this router, do the same thing over on the switch, do some pings. Let's go ahead and do the ping on the router. Let's make sure we can still ping the layer 3 switch. Let's do a do ping to 2.2.2.2, and we can still ping that layer 3 switch. So now let's do the static route on the layer 3 switch and ping over to this router. All right, so let's go ahead and do that. All right, so we're connected back into the switch. So let's do a exit. Let's do a do show IP route. We should still see that EIGRP route, and we do. We see the D right here, and that stands for EIGRP, and we can also confirm by the administrative distance of a 90. Okay, so now we want to change the routing table to have a static route instead of this EIGRP route. So let's go ahead and configure the static route. Let's do an IP route to 1.1.1.1. We want to do a /32 subnet mask, so 255.255.255.255. And the next hop will be 192.168.1.1. All right, that looks good. Now let's do a do show IP route, and we can see the route to 1.1.1.1 has changed to this static route, and we have an administrative distance of a 1. All right, so now let's do a ping to the router. Make sure we can still ping the router. So do ping 192.168. Excuse me. We want to do it to the loopback interface. So we want to do a ping to 1.1.1.1. And yes, we can still ping the router. So I do appreciate you guys watching this video. That is the end of this lab, and I'll see you in the next one.